Hi gents, it's Mr. Holding here, and this video is just quickly going through the second of the 9 Science A experiments, assessments, and this one is the energy in food prac. Okay, so there'll be a couple of documents, obviously your prac report, your assignment report, okay, and then this one here as well, okay, which goes through it. So we'll go through this one very quickly. You know, you should have gone through and done your energy and your background information through here already, determined what your aim is. Okay, so what are you actually investigating? Okay, your hypothesis is given to you. It is hypothesized that if all other factors are equal, then the food with the highest fat content will store the most energy. So that's what we're predicting will happen. We need to work out whether that's actually the case. Our materials, we've got our small metal basket, okay, there. We've got our samples of our food, our biscuits, crouton, pasta over here, and our potato chips. All right, we've got our thermometer. Okay, we've got our retort stand, Boss clamp, and our clamp, a Boss head and our clamp. We've got our large test tube here. We've got our Bunsen burner over here, and of course we've got our measuring cylinder as well. Okay, you should have done your diagram. So there's a good picture of the diagram here on chapter 3.7. Okay, so depending on what your teacher says, my class will be basing their diagram on that. And then, of course, here is our method here. Okay, so if we work our way through our method, we go through there. So first of all, the test tube was attached to the retort stand using the clamp. Okay, mine's a bit wobbly here, so hopefully you don't have one that is like that. Okay, 30 mils of water. So I've pre-filled this. Okay, I've pre-filled this one with 30 mils of water, making sure my eye level is at the level of the 30 mils, so that I account for any parallax error there. Okay, so I'm very carefully going to measure that and pour that into the test tube. Okay, so I've done that one. Okay, we want to put a biscuit onto the balance and find the mass. So we're going to start off here doing that. Okay, so we need to go about measuring our food samples now. So you can see that I've got my standard little thing here. Doesn't matter what it is, but when I put it down there, it weighs something. Okay, so I want to zero that. Okay, which means to take it off, it should go negative. Okay, the reason why I want to do that is I want to measure the weight of my biscuit, not the weight of my container. So I've tared it so that it's 0. I weigh that in. Okay, it's 1.3, okay? So from there, I've got 2 bits I can put in my table right now. So I know the mass of my food is 30 grams. Sorry, 1.3 it was, or whatever it was. Okay, you obviously need to be far more accurate. And my water is 30 mils. Okay, so I've recorded those in there. Okay, so now we've got our, we've measured our things. It's about, we want to go and heat our water. So we've got our 30 ml of water in a beaker. Okay, we need to measure the initial temperature. So I've gone and I've had this in there for a little bit just to measure the initial temperature. Okay, and I've gone down making sure my eye level is at the level of the line, and it's at 19 degrees Celsius. So without waiting too long, because we don't want to have the chance of the water temperature changing for some other factor, I want to then go and light my biscuit. Okay, so I do that. I carefully making sure that the Bunsen burner is closed. I light my match. Okay, and then I turn it to the heating flame. Okay, so what we want is we want this to ignite like this so that it's on fire. Okay, and it can be a bit tricky to get it lit. Okay, as you can see, I've my biscuit there is heating up the water. So you just need to be very careful with this. Don't want too many people walking around because you don't want to blow it out. It will go out fairly easily. And you'll see that it starts to get blacker and blacker and blacker. Okay, you may find it goes out, so you can relight it if it does go out, or if someone accidentally blows it. Okay, I have got my Bunsen burner still going, so you need to be mindful of that and be very careful. So I can half's gone out, but I can still see a red flame going. It's only a very small flame, which you probably can't see. Oh, gone now. I'll see if I can get it relit. Okay, I'm finding a bit of trouble getting it relit here, which suggests it's probably run its course. Oh, I've got a bit of a flame there going. So I continued that rather than making you watch through it for 10 minutes. So I continued through that, and I've ended up with a situation where I cannot light the biscuit. It's gone. It's burnt out. So there's nothing left. So I've exhausted all here. So what I need to do now is, as quick as I can before it cools down, is let that sit for a few minutes and try and work out what the difference in temperature is. So what's the final temperature after I've heated it up? So what I've found is that after the heating from the biscuit, my final temperature is 34 degrees. Okay, and that allows me, now I've got those four figures, so 1.3 grams of biscuit, 30 mils of water, 19 degrees was the initial temperature, 34 was the final. I can go and answer E, F, G, and H. So E, the increase in temperature, is D minus C, so 34 minus 19, so it's a 15 degrees change in temperature. All right, my energy in food is 4.2 times 30 times E. Okay, so using my calculator, 4.2 times 30 times E, which is 15, equals 2,025 joules. Okay, because it's measured in joules here. And then the energy in the food in kilojoules, the first one is joules, the second one is kilojoules, we divide that by 1,000. So it's roughly 2 kilojoules. Okay, and finally, our energy per gram of food, we want G divided by A, so 2.025, I'll leave that whole number in there, divide that by 1.3 grams, and it's 1.5 kilojoules per gram. Kilojoules per gram. So you don't have to write the units in because they're already written in the table over here. Okay, so that's the one for the first one. Now the next bit down here is the sample calculations. Okay, what that is asking you to do is to show how you got E, F, G, and H. Okay, so I did them on the calculator. You actually need to do them for one of them. I would suggest just do it for the first one. Okay, so change in temp equals D minus C, which equals 34 minus 19, which equals 15 degrees Celsius. All right, so that's the first one, and I've given an example there. The next one might be is energy in food. Okay, which equals 4.2 times 30 times E, which equals 4.2 times 30 times 15, which we know equals 2,025 joules. Should have put, we're answering that. And then we can turn around and go, well, divide 2,025 joules divided by 1000 equals 2 kilojoules. Okay, so I've shown that one there, and then that's how I've got this one here, and then finally, energy per gram equals kilojoules per gram equals G divided by A equals 2 divided by 1.3, A is up there, equals 1.5 kilojoules per gram. Okay, so I've gone through for my first one, biscuit. I've worked out calculated the mass, 1.3. I accurately put in my 30 mils of water. My initial temperature was 19. After I heated it, it was 34, which is a difference of 15 degrees Celsius. I then calculated the number of joules, okay, using the equation, and then converted that to kilojoules. And then finally, I calculate that my biscuit has an energy of 1.5 kilojoules per gram. Okay, now it's that we're going to use to compare the other one. So you now need to go and do the same, repeat the biscuit, because you'll probably come up with your own. Then do the same for chips, pasta, and crouton. With regards to the sample calculations, you only have to do it for one to demonstrate how you come up with those figures. Okay, a couple of other things that's important to worry about is that it doesn't have to be exact, because you'll notice the calculations take into account weight. However, I would suggest strongly that you try to match the chip weight with the biscuit. So if you've got 1.3, try to have 1.3 grams of chips, 1.3 grams of pasta, or 1.3 grams of crouton. If it's getting too tricky to get it exact, just get as close as you can. The water volume, same. Do it as accurately as you can. And of course, your initial temperature and your final temperature should be accurate. Don't reuse the same water. Okay, so tip it out, flush it. Okay, and then put fresh water in. Okay, so it starts at that lower temperature. Okay, from there, you need to go through. The discussion is done for you, both parts, and then you have to write a conclusion. Okay, so results of the experiment demonstrated that, and then based on what your aim is, answer your question. If it's that the chips were the highest energy, state that. Say that they were the highest energy, containing 1 point whatever grams, kilojoules per gram. Okay, mention your hypothesis. Did it match our hypothesis? Okay, and go from there. Okay, so that's pretty much it. It's important that you take your time with this, be as accurate as you can. Okay, it will take you the whole lesson, so make sure you've watched, you know what you're doing before you start. And if you have any questions, feel free to come and ask. All right, hope you found this helpful.